distinguished guests, fellow researchers, and delegates of the 16th International Conference on Interdisciplinary Research for Sustainable Development. Good morning. I am Dr. S. Nazrin Salma, Assistant Professor in the Department of Science and Humanities General Engineering Division at R&K College of Engineering and Technology. We are gathered here because we understand that the challenges facing our planet are not linear. They are complex, chaotic, and urgent. My keynote today is titled Accelerating the Path to Sustainability, AI as the Catalyst for Interdisciplinary Discovery. For the next few minutes, I want to explore how artificial intelligence is not just a tool for automation, but a revolution in how we approach the world's most pressing environmental and social challenges through collaborative, data driven environment. The why, the urgency of now. Let's ground ourselves in the reality of our mission. The UN's 2030 Agenda established the 17 Sustainable Development Goals. These are these aren't just a checklist, they are deeply interconnected challenges spanning climate, economy, and society. However, we have a problem. Our traditional research methods are often siloed. The economist sits in one building, the ecologist in another, and the computer scientist in a third. These isolated approaches fall short when tackling problems that refuse to stay in one lane. This is where AI enters the frame, not just as technology, but as an enabler. AI acts as the connective tissue bridging natural sciences, economics, and social sciences to accelerate our progress. The what? The evidence of impact. AI's transformative potential. Is this just hype? The data says no. A comprehensive review of 792 peer-reviewed studies published in Nature Sustainability demonstrate that AI has a remarkable ability to enhance efficiency and drive sustainable outcomes. We are seeing this in three key areas: forecasting, system level thinking, and predictive power. Deep learning is allowing us to predict complex climate trends with unprecedented accuracy. AI allows us to integrate ecological, economic, and social data streams simultaneously, revealing patterns invisible to the human eye. We can now forecast environmental changes and their economic ripples with high reliability. Seeing the planet in new ways. Consider our ability to monitor the Earth. In the past, tracking deforestation took months of manual data collection. Today, AI-powered analysis of satellite images reveals deforestation patterns and land use changes at a scale and speed that was previously impossible. We aren't just watching the planet, we are understanding its pulse in real time. The how, bridging disciplines, bridging environmental science and economics. So, what does this interdisciplinary work look like in practice? Let me give you three concrete examples of how AI bridges the gap. We can now simulate interactions between climate change and agriculture. Studies predict significantly yield reductions of up to 17% by 2050. AI helps us prepare for this reality. And machine learning isn't just counting costs, it's revealing benefits. It shows us the longest term economic gains of sustainable investments, such as job creation in green sectors and reduced public health costs. Perhaps most importantly, AI helps to minimize political bias. By focusing on empirical evidence, we can drive practical climate solutions grounded in scientific consensus, not opinion. Leading initiatives. This is already happening at top institutions. Look at the Cornell AI4S initiative. They are integrating AI with energy systems and food security across 16 graduate programs, fostering academia industry partnerships. Similarly, the Cambridge AI for Sustainability program is developing tools for biodiversity conservation that respect planetary boundaries. These programs are the blueprint for the future. The critical challenge, the environmental cost of AI. However, as responsible researchers, we must face a hard truth. There is a dark side of this technology. The infrastructure powering AI, the data centers, consumed 4% of total US electricity in 2023. Training large language models requires thousands of GPUs running for months, massive water consumption for cooling, and creates growing electronic wastes. Research from Penn State projects that this energy consumption could triple by 2028. If you are not careful, the environmental footprint of AI could undermine the very sustainability effort we are trying to advance. Balancing the innovation. This brings us to our critical juncture. We must balance innovation with environmental responsibility. The future of AI and sustainability depends entirely on our ability to reduce the technology's own impact. The solution and the conclusion. So, what is the path forward? AI proposed three principles for sustainable AI. Low energy AI. We must develop energy efficient algorithms that deliver results with a smaller carbon footprint. We need frameworks like SCAIS to evaluate the social and environmental cost of an AI model before we build it. We need computer scientists talking to environmentalists to ensure ethical standards are met. So, ladies and gentlemen, to conclude, AI holds unprecedented promise to help us achieve the sustainable development goals, but success requires a critical balance between analytical power and environmental stewardship. My call to action for you today is this: invest boldly in sustainable research, foster collaboration across boundaries, and embed ethical principles at the very core of your development. Thank you.